Welding is one of those essential processes in the motorsport fabrication industry. Traditionally, that's been either MIG or TIG. However, laser welding is becoming more and more prominent. We're here with Evan from Serra Laser to talk a little bit about laser welding. Now, first of all, laser welding at the moment, it is still a reasonably expensive process compared to enthusiast level TIG welders, for example, isn't it? Quite an expensive unit.
Yes, that's true. The prices are quite a bit more than your garage level welding systems, but they're close to being on par with an industrial style system.
That being said, these aren't currently being targeted at enthusiast level fabrication shops, are they? This is a professional production level product.
Yes, that's true. There are quite a few people who are using them in their garages, a few artists and custom fabricators, but a lot of times they're being targeted towards a production environment.
All right, let's talk about the differences in terms of pros and cons between TIG welding, which is generally the go-to if we want a lot of control over the weld, a lot of control about the amount of heat that we're introducing into the parent metal. Compare that to laser welding, pros and cons.
Okay, so we're introducing just enough heat that we need to weld the material effectively without wasting energy going into the surrounding material. So our energy is 200 times as energy dense at the point of welding, so our energy is just focused where we need it and not anywhere else.
So this means that there's less heat just being put into the material, the heat affected zone is narrower?
Yeah, the heat affected zone is much smaller, you retain the material's natural properties much better, and that creates a stronger weld.
So is this also useful for some of the materials that are very prone to being affected by heat, like chromoly? Could you use laser welding for chromoly welding?
Sure, yes you can.
Now, in terms of the actual technology itself, obviously the laser is being used to essentially meld and fuse the parent material together, but you do have a filler wire. So when you look at the actual unit, it almost looks like a mix between a TIG and a MIG welder. Talk us through how that works.
Sure. So the laser welder can be used as a fusion welding machine as well. If you have perfect fit up, you can fuse the parts together, called an autogenous weld. But if you want to add a filler wire or you have small gaps to fill, you can add a filler wire, and that filler wire actually moves your welding gun along and produces a perfectly consistent result. That's my favorite way to use it.
So the filler wire basically pushes the gun along the weld, so your travel speed along the weld is essentially controlled by that wire?
Yes, that's exactly right.
In terms of the controls that the welder has access to, what knobs have we got to adjust here?
So we start most welds with a preset mode. There's some preset conditions that are really well thought out that'll get us through most of our welding applications. And from there, we can dial the power up and down to achieve more or less penetration. And we can also do some control of the width of the weld. The laser wobbles side to side, and we can control how wide it goes and how fast it wobbles side to side also.
Okay, so a reasonable amount of control in there. Some of the demonstration pieces that you're welding there are relatively thin pieces of stainless, and the impressive part there is just witnessing how little distortion there is of the material once it's been welded. But on the flip side of this, how thick can we work with these machines?
So depending on the model, we can get full penetration up to 1/4 of an inch. It's not limited to the material thickness, but you can get 1/4 of an inch penetration into the material.
Now, normally if we were maybe MIG welding or even TIG welding 1/4 inch plate, it's going to require quite a bit of prep work on the weld area. We're going to probably have to chamfer or V out that weld so we can get that full penetration. What's the preparation required with a laser welder?
So with the laser welder, the best bet is to make the fit of the joint as tight as possible. We don't need a bevel and we don't need a gap. The laser has no problem penetrating deeply into the material. That's what it specializes in. And so we can just have a complete butted up joint and get full penetration right through. Even in the middle of a plate where there's no joint, I can penetrate all the way through.
All right, let's talk about shielding gas. I mean, this is essential for MIG and TIG, no different here with the laser. You're still essentially heating the base material up and to a point where it would react with atmospheric air. So what's the shielding gas you use?
So the most common shielding gas that we're going to be using is nitrogen. That's the optimal gas for steel, stainless, nickel alloys, copper. You can also use it for aluminum, but argon is recommended for aluminum, and you will need to use argon with titanium.
Okay, so typically for TIG welding, we would be using argon. Is there a benefit in terms of cost for nitrogen over argon?
Of course, yes. Argon prices are rising. Nitrogen is our most abundant gas in the atmosphere, and it's fairly easy to generate. Many of our customers have nitrogen generators for their laser cutting machines that they then use that nitrogen to use as the shield gas for the laser.
So again, this works into the hands of those who are working at production levels, doing a huge amount of welding. In terms of the speed, once everything's prepped, in comparison to TIG and maybe even MIG, can you let us know where laser welding lies in terms of outright speed?
Sure. It's said to be twice as fast as MIG. I've seen it go quite a bit faster than that. And as far as TIG goes, if you're on a long linear application on thin materials, I've seen it go up to 10 times as fast. But on average, I would say it's 4 times faster than any other handheld welding process.
Okay, that is a massive saving in terms of time, again, at production levels. Now you've got a couple of options here in terms of what the finished weld looks like, and you've got a pulse mode which almost replicates the look of a nice stacked dime weld that we're used to seeing with TIG welding. What are the two modes? Is that stacked dime give us any benefit, or is it a visual thing only?
So yes, the typical weld is very smooth and high speed. The stack dime look, we actually found out by accident that it has the benefit of allowing us to go slower. So on really tricky applications such as rounding a pipe on a stainless steel exhaust, that pulse mode allows us to slow down and get finer control, and that's something that's been really beneficial to us.
In terms of fit up, which you've mentioned, obviously again, if we compare conventional welding techniques, TIG welding does require a pretty good fit up. Maybe not perfect, but the better the fit up, the better the result. MIG welding, obviously you've got the benefit of being able to fill in some reasonable sized gaps. This one more in line with TIG welding, or does the fit up need to be even better than what we could get away with TIG?
So it's more in line with TIG welding. My rule of thumb is I try to keep the gap smaller than my wire diameter, which I typically use 0.45 wire. You can definitely fill gaps that are slightly larger than that with some gun manipulation, but the tighter fit up the better, and it's going to give you an easier result.
Now, coming back to the purging gas, you've mentioned there nitrogen, welding on some of the more reactive materials like stainless steel, typically with a TIG we would back purge. It's safe to assume that that's still something that you'd recommend using laser welding?
Yes, definitely. We'll back purge with nitrogen and weld with nitrogen.
And no differences in the techniques of how we actually go about the back purging?
Nope, same exact thing.
Perfect. Now, if someone wants to find out more about these products, and again, I'll reiterate, they are definitely a little bit more pricey than your average TIG welder. They're not really designed for the average home enthusiast, but if someone is in the market for something like this, where are they best to go?
All right, so you can search the internet. I work for a company called Serra Laser. You can go to serralaser.com. That's SERRALASER.com. And the product that we're using is the IPG LightWELD 1500 laser welding system.
Perfect, and we'll put some links to those in the show notes as well. Hey, thanks for your time, really appreciate it.
Thank you.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.